Listen,
Less than 11. Well, here's what I'm going to say is, at this point, they're going to say you have to tough it out through the semester. They're not going to,
I mean, I made it longer than Jake.
There you go.
We're all doing better than Jake.
There you go. Okay. We are talking about continuity today, and that is a huge topic in calculus and what it means for a graph to be continuous or to have continuity. And then we are also looking at limits, which you've seen a little bit with limits over the years. But, we'll look at a little bit of, I believe I recall, like how limit notation works and just a little bit about limits in general. Because when we talk calculus, there are three big topics. Limits is one of those. Okay, there's limits, derivatives, and integrals. Derivatives and integrals, brand new. Okay, limits is the one you might know a little bit about from previous math. So definition of what it means to be continuous. A function is continuous on an interval between the x values a and b if the function is defined for all values of x between a and b, and if a small change in x does not produce a sudden jump in the value of y. Okay. Layman's terms, you can take a pencil and you can trace the graph and never have to pick your pencil up. That's continuous. Okay? If I have to pick my pencil up because there is an asymptote, like a vertical asymptote, that's not continuous. If I have to pick my pencil up because there's a hole in the graph, that's not continuous. Okay? So just, general, we'll learn more about this. But, so what they're saying is, if the function is defined for all values of x, and if a small change in x does not produce a sudden jump in the value of y. A sudden jump in the value of y could be like what happens at an asymptote. Okay? If a function is not continuous at a value of x, then we say the function has a discontinuity or is discontinuous. Here are some examples of discontinuities. Okay? In other words, reason I would have to pick my writing utensil up. And so if you look at the first one, there's a vertical asymptote at A, yes? Even though both sides are going up to positive infinity, there's still that asymptote. B, I guess I'll say example B. It's another asymptote. This time, definitely not, because they go opposite directions, right? C, I would have to pick my writing utensil up to continue that graph, wouldn't I? Okay. D, there's my example of a little hole. And E, there's a hole, and the graph is defined at that point, but at a different value. So again, I have to pick the pencil up. All of those are examples of discontinuities. Okay? The A and B graphs have what are called vertical asymptotes. Already mentioned that. And these are vertical lines that are approached but never touched by the graph of the function. Okay. So a little bit about that definition. We'll talk lots more as the year goes on about continuous, discontinuous, and what that means. Left and right-handed limits. Okay. Calculus is based on a concept called the limit of a function. The limit of a function is the number that the value of the function approaches as x gets very close to some designated number. Okay, so when we talk about the limit, if we're talking about the limit as x approaches 2, we're talking about, okay, what is the y value when x is getting closer and closer to the x value of 2? What is the y value at that point? What is that getting closer to? Okay, and I've got some, if I recall correctly, there's graphs on the back, and we'll kind of talk about how the idea of limit works in respect to that. Two of the most important limits concern the values of the following expressions as the value of x gets closer and closer to 0. So these are just kind of, unique ones. Okay. We can talk graph, but I'm not going to talk. Do I usually talk graph on these? I don't think I usually talk graph on these. What I tend to do, And what you can do is, pick some x values and find out what their y values are. Now, do you guys remember how we can use list in the calculator to do this? I think we reviewed list. Yeah, because I know I haven't taught it to pre-cal, so it had to have been you guys. We practiced a little bit with list previously. No, wait a minute. I don't want to use list here. What am I thinking?
I'm not sure.
Yeah, and sorry, it's taking me a moment, isn't it? We want to use the table. That's what I want to use. Okay, let's go ahead and graph this. Sorry. Should have prepped a little bit better for that one. Forgot what I was doing here. Okay, so first of all, can you guys even read that? I know you probably can't. That exponent is 1 over x. I know that's so readable. So this is the function, or the equation, parentheses, the 1 plus x raised to the power of 1 over x. Okay? And we are trying to look at what happens as we get closer and closer to 0. So I'm going to go ahead and do a zoom 6 and graph this. I feel like this will work better if I turn this light off. I feel like there's a big glare there. Oh, I turned it on. It was off. Okay. Well, you guys, did your graph turn out similar to my graph? It did not?
Are you in the green mode, Ethan?
Oh my goodness.
The green mode doesn't matter on this one, though, or it shouldn't. Did you do a zoom 6? Did you do 1 plus? Okay, wait. I got it. You can't do a fraction bar, can you? So you have to put in parentheses. You want to do 1 plus x raised to the power of 1 divided by x. In parentheses. If you can't do the fraction bar. I bet that's going to solve your problem. Okay. Because what your calculator was doing is it was doing the power of 1 and then dividing this whole expression by x. That's what your calculator was doing. Not what you told it to do, not what you thought you told it to do, but okay. Problem solved? Yeah, make sure put parentheses around it always if it's supposed to be a fraction, just to be safe. Okay, so now we are trying to find out what this graph is doing as, what was it? The value of x gets closer and closer to 0. So as x gets closer and closer to 0, where am I looking at on my graph? Not in terms of the y value getting closer to 0, the x value. Where is x equals 0? Okay, or in other words, in general, the y-axis. Okay, so we're looking at, okay, what's happening there? And if we just do a trace, can we kind of trace and look? Now notice when I hit trace, 0, at x equals 0, does y exist? Y does not exist, okay? But the limit still exists because we can still have a limit because it's what value are we getting closer. Now, if you look at either side, okay, so like if we come up from the right, I'm getting closer to 2 point something, right? I got 2.39, 2.53. So from the right, I can see it's getting close to 2.53. What about if I come in from up above from the left? 4.65, 3.79, 3.29, 2.95. So right there, I can tell it's somewhere in between 2.5 and 2.9. That's not very precise yet. Okay, and so this is where, I should have reviewed my calculator, how we do this on the calculator. We're going to look at the table. Now, you have to already have graphed it to look at the table. And Do I go into table set? Is that what it is? There's the setup. How do I get to the table? Where's the table button? Ah, there it is. Okay. So table is second above graph. And right now, who knows what I last used my calculator for, okay? So keep that in mind. What did I last use table for? Well, my x values are ginormous, aren't they? Are those the x values I want to see? No, I don't care what x is doing in the 60,000s. Not for this problem. I care what x is doing around 0. And so where I started off is table set above window. So my table start, I'm going to put 0 because we want to know what is going on around 0, yes? Now, delta table, do I only want to see every 1,000? Not really. Less than everyone. Yeah, I want to go like with decimals, and I'm trying to remember how I did this. I'm going to say point, I don't know, so on here I have, and we can come back and change this, realize. I'm going to do 0.01. Honestly, that might not be enough, but it'll get me in the ballpark, okay? And then if I go back into my table, so second in the graph button, now notice that 0 has an error, which we saw the hole at 0, didn't we? So it should be an error there. But, okay, can you see a little bit better from either side? And if you arrow up, you can see the negatives, which is why I just put 0. Because can we see from both sides now? I can see from both sides. So now we're getting closer. Can we at least agree it's 2.7 something? Because it's 2.7048 on the positive, 2.732. Okay. I'm going to go back to my table set for a moment. Second window. I'm going to go 0.0001. I'm going to go back to my table. Okay, and your table start, you might want to re-put 0 because mine had kind of changed. And if you re-put 0, okay. Now, I said 0.0001, didn't I? It defaulted to absolute value, or not absolute value, scientific notation. Realize that's what that's saying, though, right? 1e to the negative fourth is 1 times 10 to the negative fourth, which is, whoops, 1, 2, 3, 4, which is what I put, isn't it? Okay, and so then notice it's 0.002, 0.003, so on and so forth. Is it even better now? Can we tell what my y value is getting closer to? It's more precise, isn't it? Because from both sides I have 2.718, except on the positive side I have 2.7181, 2.7184. If we add another decimal place, might we get it more precise? It's possible. Now, does that number ring a bell for you guys? That is E. Yep, it is. Okay, so, have I kind of explained how the table works there and can help you? Okay, it's not something we use a lot, but it's a good kind of tool to have in your pocket for when you do need it. In terms of what to write down here, okay, the x values I've written down in my notes aren't really the x values we used. So how about if we have, I don't know, I'll use these this time. So I'm going to go out to 0.0004. And at 0.004 it was 2.7177. At 0.003 it was 2.718. 0.002 was 2. Oh, wait a minute. That was supposed to be 2.7179. Now it's 718. And that 0.0001, 2.7181. If I put some negatives on the other side, negative 0.0004 is 2.7188. Negative 0.003, 2.7187. Negative 0.0002, 2.7186. 0.0001 was 2.7184. Okay. And obviously at 0 there is an error, right? But does that chart show us what we're getting closer to? Okay. And as I said, if we really wanted to, we could go another decimal place. Now down below it says, if we let x get extremely close to 0, we find that the value gets extremely close to e. And for reference sake, e is 2.718281828 is what I have written down. And that's just the e out of the calculator. Okay. Using the graph itself, that would have been hard to figure out, wouldn't it? I wouldn't have been able, I knew it was between 2.5 and 2.9. That doesn't make me think 2.718. Okay. Okay. Can we try the same thing with the other one? Now, realize I never typed that function in other than the graph, right? So in order to use this next one, you have to go type the function into the graph. So I'm going to go over into my graph. I'm going to clear out what I had. I'm going to do sine x over x. Shall I save you now and ask, are we all in radians? If you're not, get there. And then I'm going to go ahead and go to table set. Might as well just start there, right? Table start, well, again, we're trying to look at what happens as we get closer and closer to 0. So the values I want to go around are 0. Now, not knowing exactly what this one's doing yet, we could go ahead and say the 0.0001, couldn't we? Or we could go a little bit, I guess we didn't look at the graph of this, did we? I skipped over that step. I'll do the 0.01 because I don't remember how this looks. And if I use the table, without ever looking at the graph, can you tell what's happening here? As my x values get closer and closer to 0, what are my y values getting closer and closer to, other than error? 1? I mean, 0.999, and they keep getting closer and closer or something, don't they? Okay. So, and if you want to, you could take a peek at the graph. And I think if I recall, yeah, this one kind of oscillates a little bit. As a random side note, the menu, you have a Z trig. It's not always the best, but it does tend to work a little bit better with trig functions. And it just kind of, in this case, it zooms in, but also you can tell like it's going through pi and 2 pi and things like that. Now, does this support our theory? That as x is approaching 0 from the right and the left, what y value is it getting closer to? 1. So that supports the theory that we had in the table, didn't it? Okay. So I'm going to write down information. And this one, I'm just going to use the ones we had. 0.03 is the first one I'll randomly start with. 0.99985. 0.02. 0.99993, I think that says. 0.01. I think it's 4 9s and an 8. And when we looked at the negatives, I think they're the same, aren't they? Yeah. Negative 0.03, negative 0.02, and negative 0.01 are the same as the others you had. Okay. So, if we let x get extremely close to 0, we find that the value of sine x over x gets extremely close to 1. You will notice down there it says we use the idea of moving along the graph as we approach the x value specified. Think ants walking. Limit answers always correspond to y values, and then it says look at the following graph, which we'll go to the back side. Okay, so let's look at some of these graphs and make sure you guys understand how limits work. Okay, we have a graph. You have the same graph, right? Notice on the graph is the function f of x. Notice f of x is in 2 pieces, isn't it? Okay, and so we are being asked 4 different questions about it. And it says, A says the limit, and how I read this is the limit as x approaches 5 from the positive direction of f of x. Do you guys see that little plus sign there? Squinting, it's there, I promise. Okay. If it just says the limit as x approaches 5, we want to look at both directions and where they meet, or if they meet. If it just has a positive, then we're going from the positive side, which means as x approaches from the right. If it has a negative after the number, that's saying as x approaches from the negative direction, which the negatives are on the left. Does that make sense there? So when you see that little, I promise that's a little plus sign there, okay, I think or read as x approaches 5 from the, I always say right. Officially, I should probably say from the positive direction, but it's as it approaches from the right. Okay? That's what that little plus sign is there. So, okay, look at your graph. As x approaches 5 from the right. So that means I'm going to get over on my right end of the graph, and I'm going to start tracing, and I want to know what the y value is when I get close to 5. And where is 5, by the way? It's down here. Thoughts on your answer? Doesn't matter that the graph doesn't exist. We're talking about a limit. Yeah, so like as this graph gets closer, so you know, here we're at 8, then we're at 7, then we're at 6, then we're at 5.5, we're at 5.2, 5.1, 5, you know, we're getting closer and closer to 5. We don't care what happens at 5. Just as we get closer to 5. So as we're getting closer and closer, and this dot represents 5, doesn't it? So as we're getting closer and closer to 5, what y value are we getting closer and closer to? And we're getting closer and closer to the y value of 40. So your answer here is a very basic 40. It doesn't matter if the graph exists at that point because it's not the limit as x equals 5. It's as x approaches 5. Okay? Now, what's B asking?
The same thing, but from the negative direction.
Okay, the same thing, but from the negative direction, which, and again, I always say from the left. However, officially, I should probably say from the negative direction, or from, I might even be able to say as the values, the smaller values? I don't know. So, okay, so now we want to approach 5 from the left. So we want to trace our graph over on the left. So 1, 2, 3, 4, 4.5, 4 3/4, 4.9, 4.99. What y value am I getting closer to? What? 30. Okay. Again, it doesn't matter that 5 doesn't exist. It's as we come from the left, what y value are we approaching? And we are approaching that exact point, which is 30. Okay. What do you think about C? The limit as x approaches 3 from the right of f of x is equal to what? Yeah. So as we approach from the right, that means we're going to come from the direction of 5. So we're coming from here. What is the x value at 3? Even if it doesn't equal it, it is 20. What about the limit as x approaches 3 from the negative side? It would be. Because in this case, it's a continuous graph at that point, isn't it? And so they're approaching the same thing. Okay? And we don't think, I think today it's more specifically about left and right, about the individual. Eventually what this will mean is, if I just ask you what is the limit as x approaches 3, so it approaches, when you approach 3 from both sides, it is approaching 20 from both sides, isn't it? So that answer would be 20. If I ask you what is the limit as x approaches 5, and I don't give you a specific side, it doesn't exist. Okay? That limit doesn't exist because it's two different things, isn't it? Okay? So, and again, that's more for another day, but today we're just specifically looking from one side. Okay. The limit of f of x as x approaches some number, a from the right or left, is the number f of x gets closer and closer to as x gets closer and closer to a. When discussing limits, we do not even consider the value of f of x when x equals a. So it doesn't matter, open circle, closed circle, a break in the graph, those things don't matter. Okay? So, given the graph of f, estimate these things. Guess I could be right here, couldn't I? Okay, so A, the limit of f of x as x approaches 3 positively. So from the positive side. What do we think here? 2? You guys okay with that? So as we approach x, so here's 3, and we're coming from the right, which means we're coming from this up above graph, and it goes to that open circle there at 2. Okay. What about the limit of f of x as x approaches 3 negatively? So here's 3, right? So we're looking, so from the left, it's this portion of the graph that's approaching, and it's approaching a y value of 1. What about the limit as x approaches 1 negatively? So 1 from the negative side. 1 also? Are you guys getting these? You getting them right? Because this time we have to come over here, and it goes down to 1. Limit as f of x as x approaches 1 positively. Okay, we're following this graph to the right here, and it approaches 2. As x approaches, that's an x value. Your answer is always a y value. Okay? Good. Continuing along unless you have questions. Stop me if I need to explain something better. Okay. The limit as x approaches 3 from the positive side of f of x. Thoughts on this one? It's x equals 3, right?
Positive direction.
The first one is from the positive direction, which actually means we're coming from, no, where x values are positive. Sure, I don't remember. Okay, so, yeah. So we're coming from, it's actually the downhill slide, right? Because x values are bigger over at 5 and 4. So that's where we're coming for first, and yeah, approximately 40. It is just that. It did say estimate, right? So in the ballpark at 40. What about as x approaches 3 from the negative side? Yeah, it's the same thing. It's a line. And it actually, at that point it equals. So this time we're going from the 1, 2, 3 side, and it is 40. Okay. Last set. Given that f of x equals 1 when x is greater than or equal to 0 and negative 1 when x is less than 0, sketch the graph of f and find two limits. So we have a piecewise function here. X-axis, y-axis. There's my starting graph. Now, when it says f of x equals, remember f of x is the same as saying y equals, right? So it's the graph of y equals 1 whenever x is greater than or equal to 0, and the graph of y equals negative 1 whenever x is less than 0. So what's the graph of y equals 1 look like? Okay, it's a horizontal line up at 1, right? Now, officially, y equals 1 is a horizontal line all the way across, right? What section am I concerned about, though? When x is greater than or equal to 0, which is going to be the portion on the right. And at 1, it says greater than or equal to 0, so that is a closed circle, or it is defined at 1. What about the other part? It's a negative 1. So this time it's kind of like, okay, we're talking about, this horizontal line down, negative 1, but it's when x is less than 0. So over to the left. And what happens at 0? It just said x less than 0, so I'm going to use an open circle. And what it means is this falls into, yes, it is a function technically. Okay. Now that you have your graph, we have two functions, or two limits to answer. What do you think about A? As x approaches 0 from the positive side, so I'm going to go from the right, where my x values are bigger, and it's always 1 on that side, isn't it? So 1. Okay, B. When x approaches 0 from the negative side, so then I'm following my graph over here, and over here I'm down at negative 1. A little introduction to limits there. Okay, some of the basics.
I'm not intimidated.
You shouldn't be. Definitely not an intimidating lesson. We'll save those for later. They're going to happen,